Hello Godotneers! So you just downloaded the Godot game engine and want to get started with creating your game, but you don't know how to program. And then you find out that Godot's documentation assumes that you know how to program, and so do most of the available tutorials. So we are going to explore how programming works with the GDScript programming language. We will learn about the basic building blocks of a program, like functions, variables, and loops, and how we can combine these building blocks to write small programs that solve actual problems. This is a beginner-level tutorial. You should be able to find your way around a computer, so you should be able to download and install programs, and also have a basic idea of how files and folders work. We're also going to use some elementary mathematics, but nothing too fancy. Before we get started with this video, let's quickly talk about what you can expect from it. This video will teach you the absolute basics of programming. But programming is very much a skill like every other skill. To get good at it, you need to actually do it yourself. You will not get better just by watching tutorial videos like this, or by copying and pasting code from the internet or ChatGPT. That's why this video comes with an example project that we will use throughout the video and that you can also use for your own experiments. This project will give you a pre-made environment to learn, so you can focus on the programming part and don't need to learn the ins and outs of the Godot game engine to get some programming practice. So as a first step on our journey, let's download and open this example project. You can find a link to the project's website down in the description, and if you click this link, your browser will show you this page where you can download the example project. So we scroll down until we see this big download link here, and then we click on it, and this will download a package with the project files. Now we need a place where we unpack our project files. I will use the desktop, but you can use really any folder that you like. So let's drag this file on the desktop and then right-click and select Extract All. And then we can just click the Extract button down here. If you are on a Mac, you can just double-click on the file and it will be automatically unpacked. The next thing we need to do is to open up the project in Godot. If you don't have the engine installed already, please install it now. You can find a link to the download page in the description of this video. Be sure to download version 4.2 or a later version. You can also find the Godot engine on Steam, so if you have Steam installed, you can search for Godot there and install it through Steam. So let's start Godot, and the first thing that we see is this project manager, where we can create new projects or import an existing project. We want to import an existing project, so we are going to click this import button up here. And then in the dialog, we can navigate to the folder where we have unpacked the example project. I have mine on the desktop, so I'm going one step up to my user folder and then desktop, programming video main. And there's another programming video main folder inside of it. And inside of this folder, we have a project.godot, which is the file that we are going to open. Now we can click this Import and Edit button, and our project is loaded into Godot. Programming at its core is problem solving. When you program something, you look at the problem, and then you come up with a series of steps that need to happen to solve this problem. And this is something that you already do every day, all the time. For example, if you want to cook a dish for supper, you'll prepare a little program for yourself in your head. So you say, oh, I need to go to the grocery store, I need to buy ingredients, I need to find that recipe in my recipe book, and then you follow the steps of the recipe, and finally, you serve the dish. Or if someone asks you for the way to the next grocery store, you prepare a little program for this person. So you say, okay, you need to turn around there, and then you walk 300 meters until you see a blue sign, and then you turn left, and then you walk another 150 meters, and there you are. But there's a very big difference between your everyday programming and programming a computer. And this is that computers are not intelligent. If you tell a person to pick up a coffee for you, that's really all you need to do. The person will come up with the steps on their own, and they will just pick up the coffee and bring it back to you. But for a computer, you will have to give detailed and precise instructions for every step of the way. The computer will do exactly what you say to it, and not necessarily what you mean. Let's explore this and write our first computer program. So we still have the project open that we imported as our first step. And here in the main window, we can see our welcome scene. If you don't see it, you can click on the welcome.tscn file here in the file system dock. You can use the mouse wheel to zoom in, or if you don't have a mouse wheel, you can also use the zoom buttons up here to zoom in and out. You can click and hold your middle mouse button or mouse wheel and drag this around so everything is nice and centered. And if you don't have a middle mouse button on your mouse, you can also press the spacebar and keep the spacebar pressed, and then press the left mouse button and drag stuff around. You can also use the scroll bars here on the side to change which part of the scene you want to see right now. Now in our welcome scene, we have a little room, and we have our buddy, Mr. G. Now we want Mr. G to pick up this coffee and put it on the pink field here. To program anything in Godot, we need a script. A script in Godot is very similar to the real-life script that actors get on a movie set. It contains all the instructions that are important for the actor, so the actor knows what to do and when to do it. And here in the Godot engine, we also use scripts to tell our game elements what to do and when to do it. There's already a script in our project, which is named welcome.gd. So let's double click on the script so we can see what is inside. Well, we have some text here that reads extends stepping robot and a func what should I do? Well, now that reads somewhat like English, but it's written very strangely. And here under what should I do, we can see a list of instructions. Step forward and turn left. They are also written somewhat strangely, but well, maybe this is the way computers talk. So let's hit the play button up here, and we want to use this play button, not the other one, to see what it does. And it would look like Mr. G is following these instructions. So he walks a step forward and he turned left. Okay, so how would we need to change these instructions so that Mr. G walks right up to the coffee pot? Well, let's open our script again. And if we want to see both the scene with Mr. G and our code at the same time, we can click the little icon up here to pop out this editor into a second window. And if we don't want the second window anymore, we can just close it. We can also click on Script up here to switch to the script editor, and on 2D if we want to see the scene with Mr. G. So we already have one step forward command in here, and to be right before the coffee pot, Mr. G would need to step 2 more steps forward. So maybe let's delete this last line reading turn left, and then copy and paste this line 2 times. Okay, looks like the editor is not happy with this. The line is red, and we have some error message, unexpected identifier in class body. Now, what did we do wrong here? Well, let us see what is the difference between this first step forward and the other 2. Well, it is that the first line has some space before it and the others don't. Okay, Let's try if we can just add a few spaces before these lines so they look like the first one. So we add a few spaces here and we add a few spaces there. The editor is still not happy, but this time we got a different error message. Use space character for indentation instead of tab, as used before in the file. And if we look at the first line very closely, we can see that there's a little like inverted K at the start of the line, but it's not here on the second and third line. So how do we fix this? Well, in programming, there are two ways of adding spaces at the start of a line: spaces and tabs. Spaces are done with the spacebar of your keyboard, and tabs are done with the tab key. Where the tab key is on your keyboard differs a bit depending on which kind of keyboard you use, but usually it is on the left side of the keyboard. Okay, so let's see what happens if we use the tab key instead of adding 4 spaces. So we delete these spaces, and now we press the tab key, and we get this little tab indicator, our inverted K. Well, let's fix up the second line as well, and then we can try it out. We press the play button up here, and Mr. G is nicely walking up to our coffee pot. Hey, we've just written a program in a GDScript programming language. Nice. Okay, now Mr. G should pick up the coffee pot. How would we do that? Well, let's start by typing pick. And we can see that the editor offers us some help. This is called an autocomplete or code completion pop-up. It is similar to what you get when you type text on your smartphone. Here the editor shows us everything that it knows about things that have pick in their name. And the first entry actually looks like it could do what we want. So let's press the tab key here, the same we just used to add the space to our lines. And the editor will now automatically insert this instruction into our script. Okay, well, let's see if it works. We press the play button. And Mr. G walks up to the coffee pot and picks it up. Nice. Now we want Mr. G to bring the coffee pot back to the pink square and drop it there. So which instructions would you give to Mr. G then? Well, maybe pause the video here and try a few things in your project, and then continue with the video to see my solution. So first, Mr. G needs to turn around. Well, let's see what the editor offers us when we type turn. It looks like we have turn left and turn right, but not turn around. But this is not a problem. We can just tell Mr. G to turn left or turn right 2 times. Either thing will work, so let's try turn left 2 times. And then 2 steps forward. And then Mr. G can drop the item. Again, let's type drop to see if the editor can help us. And the first entry is drop item, which sounds like the thing that we want. So let's press tab to use this one. Okay, our program is done, so let's give this a try. So Mr. G goes to the pot, picks it up, turns around, and drops it right on the pink tile. Fantastic. So far, we have given Mr. G just some simple instructions. And we always wrote these instructions in this peculiar way. So what did we actually do here? Well, we used existing functions that Mr. G has and asked him to perform these functions. Now, what is a function? In programming, a function is a self-contained mini program that we can start again and again. And this way, we can reuse functionality that we need often. Running the program of a function is called calling the function in programming. So we will use this term from now on. Remember when we tried to tell Mr. G to turn around? We only had functions for turning him left or right, but we can write our own function for turning him around. Writing our own function is actually quite easy. We start with func, and this is a special keyword that says we want to define a new function here. And now we need to give this function a name. Let's call it turn around. And now the editor is unhappy. It says expecting open parentheses after function name. So let's add a set of parentheses and see if this improves things. And it doesn't seem to help. The reason for this is that in the GDScript programming language, like in most programming languages, there are some very strict rules about how you can name things. The most important rules are that names may only contain letters, numbers, and the underscore. They may not start with a number, and the letter casing is important. So turn around with an uppercase T at the front is a different name from turn around with a lowercase t at the front. Our function name currently contains a space, and this is not allowed, so we will need to use a different character. We could just delete the space, but that is sort of hard to read, so let's use an underscore to separate the words. Okay, that is better. This style of naming functions is called snake case, and it is the most commonly used style in GDScript. There are some other styles like camel case, or Pascal case, or even kebab case. All the styles that have a check mark follow the naming rules, and we can use either of these styles to name our things. But for this video, we will stick with snake case because that is what all the functions built into Godot use. Doing it this way is a good idea in general because then we have a consistent style of naming throughout our project. Back to our function, we can now see that the editor is still unhappy about it, and it says we need to add a colon. So let's add that. And now it says that it expects an indented block after our function declaration. Now, what is an indented block? Remember that at the beginning, we had to add tabs to the start of our lines to make the editor happy? This is called indenting or indentation. Why do we need this? Well, in GDScript, the indentation tells the computer where the function ends. Everything that is indented belongs to the function. So let's write our two turn left commands into our new function, and then let's indent them with the tab key. And now the editor is happy. So let's go up here and let's delete the two turn left commands, and instead we can type turn. And now the editor's autocomplete will actually show us our new function here, and we can use this one. Well, let's try out if this works. Mr. G walks up to the coffee pot, and he turns around, and he drops the coffee pot. Nice! So now we can write our own function. Let's also write a comment for this function so we know what the function does. We can write a comment by just writing a hash or pound sign. And now we can write everything that we want. GDScript will ignore everything after this pound sign until the end of the line. So we can write this function turns Mr. G 180 degrees. And if we want to have a second line, well, we can write another pound sign and then the rest of the documentation relative to his current orientation. Adding comments really helps us understanding our code better in the future. Right now, we know what this function does because we just wrote it, but in 3 weeks, well, it may not be so clear anymore. So adding some documentation really helps in the long run. Now let's see if we can ask Mr. G to do a little bit of mathematics for us. Let's say 1 coffee costs 2 coins, and we want Mr. G to calculate how much 3 coffees cost. Well, first let's remove the program that we have written so far. And now how would we tell Mr. G to calculate something for us and tell us the result? The GDScript language understands basic mathematical concepts, so we can write mathematical expressions like 3 times 2. So 3 coffees multiplied with 2 coins for each coffee. This little star here is GDScript's way of saying I want to multiply these 2 numbers. Okay, that seems to be valid code because the editor does not mark it red. But we have a little warning icon down here. And if we click on it, we can see some explanation that tells us standalone expression, the line has no effect. So it would seem like the editor is trying to tell us that this line will not do anything. Well, let's see if this is really the case and start the program. And indeed, nothing seems to happen. So what is the problem here? Well, we told the computer to calculate something for us, but we didn't tell the computer what it should be doing with the result. Remember, the computer will only do what you tell it. It cannot know what you mean because it's not intelligent. What we want is that Mr. G tells us what the result is, and this is the part we haven't written down yet. But how could we get Mr. G to tell us the result? Well, maybe there is a function that we can use. Well, let's try with tell, but the autocomplete doesn't seem to know anything about it. So how can we find a function if we don't know its name beforehand? Godot has a built-in help system that can help us with that. There's a search help button up here, so let's click on it, and now we can search for something. But we don't know the name of the function, so we have the same problem again. But we know the name of another function that we have used, step forward. Maybe we can find other functions that we can use if we look near the step forward function in the documentation. So let's type in step forward. And then we select the step forward function here and press open. And we can see the documentation for the step forward function. And we can see that other functions like turn left and turn right are also documented on this page. So let's scroll up to the top of this page. And here we can find a section titled Methods, which seems to list all the functions that Mr. G has. But why is it named methods and not functions? Well, a method is a special kind of function, but for now, let's not get too far down the rabbit hole, and let's just say that method is another name for function. So here we can see all the functions that we can use from Mr. G. And the one that looks interesting is say. Okay, let's click on this, and the documentation reads, shows the given text in a speech bubble above Mr. G's head. Oh, that sounds pretty useful for what we want to do. So let's try to use this function. Let's go back to our script, and we can double click it again down here in the file system part. And now let's type say, and then we press tab again to select this function from our autocomplete. But this time, something interesting happens. Our caret is now between the parentheses, and we have a little overlay with some strange text. It has a highlighted part that reads, what variant? So it looks like we now need to write what should be said inside of these parentheses. Okay, let's try writing 3 times 2. Well, that seems to make the editor happy, so maybe let's also delete this line above, which didn't work, and then let's see what this does. So we start the game, and Mr. G now says 6, which is indeed 3 times 2. Oh, so we just learned a new thing. Functions can take additional data and work with that. The say function will take whatever data we give between the parentheses and will show it in a speech bubble. Well, that is very useful, and we are going to make our own function that can do this later. For now, let's add another calculation. Mr. G should now tell us how much 4 coffees cost. We already know how this works, so let's add another line. And this time we let Mr. G calculate 4 times 2. Let's try this out. So Mr. G first tells us the price for 3 coffees. And now he tells us the price for 4 coffees, which is 8. Great. Okay, so now what if the price for coffee changes? We have written the coffee price 2 times in our program now. So we would now need to change 2 places if we want to change the price of the coffee. And if we had used this coffee price in 50 places in our program, well, we would now need to change 50 places. And this is not only tedious, but it also makes it super easy to forget one place and introduce a nice bug into our program. So what can we do about this? We can add a variable. A variable is a place where we can store a value. And this looks like this. We type var, and then the name of the variable. And here we have the same naming rules that we already know for the names of functions. So we write price underscore for underscore coffee. And then we can give this variable a value by writing equals and then 2, because 2 is right now the price for a coffee. Now we have a variable that is named price for coffee and currently stands for a value of 2. So we can replace the 2's in our toSay commands with price for coffee. And the editor is also nicely giving us autocomplete support, so we don't even have to type a lot. So let's see if this works. And, well, it is working nicely. So if we now want to change the price of a coffee, we can just change our variable up here. So let's say coffee is on sale now and only costs 1 coin. Well, if we play this, Mr. G will now use the new price. Fantastic. So how about we give Mr. G a few coins and let him buy a few coffees and see how much coins he has left. Well, let's create another variable for this, var coins. And let's say we give Mr. G 10 coins. So now Mr. G buys 2 coffees and we want him to say how much he has left after that. Let's first remove these 2 say commands. And then we need to calculate how much coins Mr. G has left after he has bought 2 coffees. And calculating this is not that difficult. We take the amount of coins. So we write coins. And then we subtract 2 times the price of coffee. And then we want to say this, so we call the say function with all of this between the parentheses. Okay, let's try this out. And Mr. G tells us that he has 8 coins left. Fantastic. So now let's buy another 3 coffees and see how much coins Mr. G has left now. We can just copy this line and change the 2 into a 3. And if we run this, we get 8 and 7? Well, that is odd. If Mr. G buys 2 coffees and then 3 coffees, shouldn't he only have 5 coins left? What is wrong here? Well, again, we didn't tell the computer all the necessary steps. Well, let's see how the computer runs this. We come to the first say line, and the computer will now replace all the variables with their values. So coins becomes 10, and price for coffee becomes 1, and we have 10 minus 2 times 1, which is 8. And on the second line, the computer will do the exact same thing. So coins will be replaced with 10, and price for coffee becomes 1, so we now have 10 minus 3 times 1, which is 7. So we need to tell the computer that he should decrease the amount of coins by the amount that Mr. G has spent. Now, how would we do this? Well, we can change the value of a variable in a similar way as we set the initial amount of coins up here. We have calculated the amount of coins that we have left already. So maybe let's do var coins equals coins minus 2 times price for coffee. The editor seems to be unhappy again. It says there is already a variable named coins. Well, but we don't want to make a new variable. We just want to change the variable that we already have. To fix this, we can simply remove the var in front of this line. And now the editor knows that we want to change the existing variable and don't want to create a new one. So let's again look at this line. We say, please set the value for our coins variable to the current value of our coins variable minus the price for 2 coffees. So the computer will now calculate everything on the right side of this equal sign and then change the variable on the left side of this equal sign to what it has calculated. Okay, so now we have changed the variable and Mr. G can just say coins. Then we can repeat this for our second buy of 3 coffees. Coins equals coins minus 3 times price for coffee. So we buy 3 more coffees. And then again, we say the amount of coins that we have left. Let's try this out. And now we get 8 coins and then 5 coins. Our program now gets a bit more complex, and repeating all these calculations over and over again is not fun. So maybe let's make another function like our turnaround function that can calculate the cost of a certain amount of coffees. This way, we can just run this function instead of having to type out all these calculations again. So let's start with a new function. So we write func, and then the name would be calculate price for coffees. And to make the editor happy, we just type pass in here, which simply means do nothing. We need to have this pass in here because in GDScript it is not allowed to have a function that is completely empty. Okay, now we have a new function, but we need to tell to this function how many coffees we want so it can calculate the correct price. So maybe let's create a variable amount of coffees in our function. And we set its value to 0 for now. And then maybe let's calculate the price for the given amount of coffees. We write var result, and this is price for coffee times the amount of coffees that we want. And now the editor seems to be again unhappy, and it's telling us identifier price for coffee not declared in the current scope. So it would seem that it doesn't know about our price for coffee variable up here. And this is because variables live in so-called scopes. Now, scope is just a fancy way of saying that variables are only visible in certain parts of our program. If we make a variable inside of a function, then this variable will only be visible inside of this function. So our price for coffee variable up here is only visible inside of our what should I do function. Now, how can we fix this? Well, there are a few different ways in which we could fix that. One way would be to just make another price for coffee variable down here. So we could write var price for coffee equals 1. Now this makes the error go away, but now again we have 2 places where we need to update the price for coffee if we decide to change it. So this works, but it isn't really nice. So where can we put the variable so that both our functions can see it? Well, we can put it here at the top of our script, outside of both functions. Everything that we put here is visible to all functions in our script. So let's remove this variable from both functions and move it up here. We also need to make sure that we don't indent this because this variable exists outside of a function. If we indent this, we will get an error, unexpected indentation. So let's fix that. And now we can go back to our function which calculates the price for a coffee. How would we now call this function? Well, let's start with calculate, and then we get autocomplete again, and we take calculate price for coffees. But we need to tell it how many coffees we want. And we just learned that we cannot see the amount of coffees variable from here because it is declared down there in our calculate price for coffees function. But we can fix this problem with a function parameter. A function parameter works very much like a variable, but instead of putting it into the function, we put it between these parentheses here. And because variables are the only thing that can go in here between these parentheses, we don't need the var keyword. It is actually not even allowed to be here. So let's delete the var keyword. And now the editor is happy again. So now we have a parameter for our function. And up here, where we call our function, we can put our caret inside of these parentheses and press Control Space. And now the editor will show us that this function has a parameter named amount of coffees. We want to calculate the price for 2 coffees, so we type in a 2 here. And you can see now how this works very much like the say function that we used earlier. There's something else that is interesting. The editor was totally happy with us calling the function without the parameter. So we can just write calculate price for coffees without the parameter, and this line is not read. Why is that? We didn't give it a parameter value, so shouldn't this be an error? Well, parameters can have default values. Right now, our amount of coffees parameter has a default value of 0. So if we leave out the parameter value when we call the function, then GDScript will just assume that we want the default value of 0. Now, calculating the price for 0 coffees really doesn't make a lot of sense, so maybe let's remove this default value here. And now we can see that our line indeed becomes red, and the error message says too few arguments for calculate price for coffee. So now that our parameter no longer has a default value, we must give in a value. Otherwise, the editor is going to be unhappy. We already did this up here, so let's just delete this line. So now we know how to get the amount of coffees into the function, but how do we get this result variable back up here? Well, functions can not only take parameters, they can also return a value to the function which is calling them. This is done using the return keyword. So after we calculate our result here, we can write return result. But how do we get the value that this function returned? Well, we can assign it to another variable. So here, where we call the function, we can write var price for 2 coffees equals calculate price for coffees 2. Okay, let's do a quick recap on how this works. We call our calculate price for coffees function, and we give it the value 2 as a parameter. Now in this function, the amount of coffees variable is set to 2. The function will calculate the price by multiplying the amount of coffees variable with our price for coffee variable up here, and store the result in our result variable. And finally, our function will return the value that is in our result variable. And then we put this returned value into our price for 2 coffees variable. Okay, that was quite the ride. So let's check if this actually works. We tell Mr. G that he should say the price for 2 coffees variable so we can see what is actually calculated. And for now, we don't want to run these lines down here, but we don't want to delete them either. How can we disable these lines? Well, remember when we added a comment to our function earlier, We know that if we add a hash or pound sign at the beginning of the line, everything until the end of the line will be ignored. So let's just add this before the lines, and now they will be ignored. This is called commenting out code, and it's really useful if we want to disable a piece of code temporarily. So if we now start the game, then Mr. G will tell us the price for 2 coffees, which is 2 coins. Okay, that works nicely. So now we can update our code which calculates the remaining coins. Let's remove these comment marks, and let's also get rid of this call to the save function here. And now we can replace this 2 times price for coffee calculation here with price for 2 coffees. And for the second calculation, we can create a new variable, price for 3 coffees. And then we call our function, and this time we give it a 3 instead of a 2. And then we can replace the calculation with price for 3 coffees. And we say the coins again. Okay, this doesn't really look like an improvement. It's now even more code than before, but we can simplify this a bit. There's actually no need to write the return value of our calculate price for coffees function into a variable. We can use this return value directly in our calculation. So we can just write coins equals coins minus calculate price for coffees 2. And then we don't need this variable anymore. And we can do the same for our second line. Also, because subtracting a value from a variable is so common, GDScript actually has a shortcut notation for this. So we can delete this second coins and move the minus before this equals sign. So now it reads coins minus equals calculate price for coffees 2. And it's important that the minus and the equals have no space between them. So they need to be directly next to each other. So this shortcut does exactly the same thing, but with less typing. And if we repeat this for our second line, well, then we get coins minus equals calculate price for coffees 3. And now if we run the program again, Mr. G will tell us the remaining coins after we have bought 2 coffees and after we have bought 3 more coffees. Nice. So we have cleaned up our function and moved all the calculations into a separate function. And this will become quite useful in the next step. Well, let's say we now want to give discounts. So if we buy 3 or more coffees, we get a discount of 1 coin. Because we now have a function that can calculate the price for coffees, we can put this logic here and don't need to change anything up here in our what should I do function. Now we need to program a decision. If the amount of coffees is 3 or more, then we want to give a discount of 1 coin. How can we express this in our programming language? Well, GDScript has a keyword called if. So to solve our problem, we could write if amount of coffees is greater than or equal to 3. And then we subtract 1 from the result, and this way we give a discount of 1 coin. The part after this if keyword is called a Boolean expression. It's named after George Boole, who did a lot of research in the field of logic. So Boolean expression is just a fancy name for any expression that can be either true or false. So this if line will check if this expression after the if is true, and if so, the indented block below the if will be run. Just like with our function, the indentation tells the computer which parts of our program should only be run if the condition is true. And that's why we don't indent the return here, because we want to return the result every time and not just when we give a discount. So now our function can do discounts. Well, let's see if that actually works. Up here, we buy 2 coffees and then we buy 3 coffees. And if our discount logic works, then we should pay 2 coins every time and should end up with 6 coins. So let's see if that really works. We buy 2 coffees and have 8 coins left. And we buy another 3 coffees and have 6 coins left. Oh, that works really nicely. Now I think Mr. G should also tell us whether or not we got a discount, so we can better see what is going on behind the scenes. So now, if we get a discount, then Mr. G should tell us about it. We can use the say function for this, so let's try this out. Inside of our if block, we write say, you got a discount. Well, now the editor seems to be unhappy about this. We get a message expected closing parentheses after call arguments. Now that's weird. We wrote a closing parenthesis after all, so what's going on here? Well, we want Mr. G to say a bit of text. But if you look at what we wrote here, the computer cannot really know which parts of the text are the ones that Mr. G should speak, and which ones are other instructions in a GDScript programming language. Should Mr. G say, you got a discount? Or should he say, you got a discount, closing parentheses, result minus equals 1? The computer cannot read our mind, so we need to be a bit more specific here. We can tell the computer which part should be actually said by enclosing it in double quotes, like this. Now the editor is happy. What we have just written is a so-called string, a bit of text. We use text very often in games to show all kinds of information to the player. And let's say we want Mr. G to tell us how big the discount actually was. How could we do this? Well, a simple way would be to just write it into our string. We could say, you got a discount of 1 coin. But now again, we have 2 places where we write the discount. So if we want to change the discount down the road, we need to remember to update these 2 places. So maybe let's make another variable for the discount. So we write var discount equals 1. And then inside of our if, we use this variable instead of the 1. And now we can also use this discount variable in our say function. But how do we get it in here? The actual discount should be printed where this 1 is right now. In GDScript, we can build new strings from smaller parts using the plus sign. So we can write you got a discount, and then we close the string, and we write a plus, now the discount variable, plus, and then another small string part, coins. This is the same plus sign that we used for adding numbers, but if we use it on strings, then GDScript will glue the parts together into one bigger string. So let's see if this works. We press play, and we got an error. Invalid operands string and int in operator plus. Oh, that's a mouthful, so let's try to decode what Godot is trying to tell us here. The problem seems to be with our plus sign. This plus sign is called an operator in programming languages. There are a lot of other operators like minus, star, slash, which do different things depending on which kind of data you use them on. For example, the plus operator can work on 2 numbers and then returns the sum of these numbers. Or it can work on 2 strings and produce a string that is both input strings glued together. The numbers or strings that we give to the operator are called operands. And now with this knowledge, we can read this message again. Invalid operands string and int in operator plus. So this tells us that we used a plus operator, and we gave this operator both a string of text, you got a discount of, and a number, our discount variable. And now the operator does not know what to do with this. it can only work on pairs of strings or pairs of numbers, but not on a mixed pair of a string and a number. So it is important which type of data is in our variables. There are a lot of different data types that we can use, but the most common types are strings, which is any kind of text, numbers, and here we make a distinction between whole numbers, which are called ints, and fractional numbers, which are called floats, and finally the values true and false, which are called booleans. Godot also provides a lot of other data types that we will use eventually in game programming, for example vectors, quaternions, rects, etc., but we will not bother with these right now. Well, let's get back to our error here and try to fix it. We now know that our plus operator only works with pairs of numbers or pairs of strings. So we need to convert our discount variable, which is a number, into a string before we can give it to the plus operator. And we can do this with the str function, which is built into Godot. This function takes any value and converts it into a string. So let's wrap this function around our discount here. And then we can give it another try. We start the game. And Mr. G prints out the 8 for our first buy, and then prints out our discount and the final amount of coins for our second buy. Nice. So we fixed this problem, but it's really not great that we only saw this problem when we actually ran the program. It would be a lot better if the editor would have told us about this problem right away. So why didn't it tell us? Well, when we declare a variable like we did with our discount, we can put any value into this variable that we want to. So I could change this line up here to for discount equals 1, which now is a string and no longer a number. And now I could write a line directly below that reads discount equals 7. So now I assigned a new value to discount, but this time it is a number and not a string anymore. So the editor really can't tell which type of data is stored in this variable without actually running our program. And that is why it cannot warn us about this problem beforehand. But there's a way to fix this. We can say this variable can only be a number when we declare it. If we want to say that the discount can only be a whole number, well, then we can add a colon and then int after the name, which is short for integer or whole number. And now we can see that the editor tells us cannot assign a value of type string as int. Because we locked the data type of this variable to int, we can no longer store strings in it. So let's fix up this one. And let's also delete this line where we assign 7 to the discount. And now let's see what happens if we remove the str function from our line here, where we build the string with the discount. And we can see that the editor now actually gives us the error right away. We don't need to run the program anymore to see the problem. And this is going to be a huge help when our programs get bigger and more complex. So when should we lock down the data type of our variables? Well, unless we have a very good reason, we should do this all the time. And we cannot only lock down the types of variables, we can also do this for parameters. So let's quickly undo this last change so our code works again. And then let's lock our amount of coffees parameter to an int. And then we can do this for all the other variables that we use in our program as well. We can even lock down the type of data that a function returns. So our calculate price for coffees function will always return a whole number. So we can add a minus greater than after the closing parenthesis. This looks like a little arrow. And then we can write int before the colon. And now this function can only return whole numbers or integers. So if we now try to return a string, by writing return result, which now is a string, then the editor will immediately tell us that this function should return a whole number and not a string. Let's undo that so our program works again. And now I think that's enough coffees. So let's leave the coffee shop and take a little walk with Mr. G. For our next experiment, let's drag Mr. G down one row, so he now is in the row with the blue tile. Let's also remove this code with the coins from our what should I do function, and we'll write a pass in here for now, so the editor is happy. Now we want Mr. G to walk to the blue tile. And we already know that we can use the step forward function for this. So let's count the amount of tiles that we need to walk over. So 1, 2, 3, 4, 5, 6, 7 tiles. Okay, so we could now write 7 times step forward. But this is a lot to write, and what would we do if Mr. G should walk 100 tiles? To solve this problem, GDScript has a functionality called loops. A loop allows us to repeat a piece of code. One kind of loop is the so-called for loop, and it looks like this: for step int 7. So we have the for keyword here, which means that we want to start a loop. And now we declare a variable called step, which will hold the current step. And this is a whole number. Then there is the in keyword. And after that, we put a number which tells Godot how many steps we want to go. And now we can indent one level and write the code that should be repeated. So step forward. The indentation works exactly the same as in the functions or the if block that we already saw. It tells Godot where the part that we want to repeat starts and ends. So right now, Godot should call the step forward function 7 times. Well, let's see if this works out. We start the game, and Mr. G slowly walks to the blue tile. Nice. But what is this step variable good for? Well, let's have a look at how we would write the same code without using a loop. It would look something like that. We first create a step variable and initialize it with 0. And then we run the loop for the first time. So we call step forward. Then we increase the step variable. So we could write step plus equals 1. And this works very similar to the minus equals thing that we already saw. And then we run the loop for the second time. And we again increase the step variable and so on and so forth until we run the loop for the 7th time. So our step variable will start with 0 when we run the loop for the first time. And it will have the value of 6 when the loop runs for the 7th time. We could use this, for example, to let Mr. G tell us how many steps he has left to go. How would we do that? Maybe again pause the video and try to come up with a solution yourself. So we know we have 7 steps to go, and we also know that the step variable will start with 0 and end with 6. So we can calculate the steps that are left to go like this. We create a variable var steps left to go. This is an int. And we set this variable to 7 minus step. So in the first loop, it will be 7 minus 0, which is 7. In the second loop, we get 7 minus 1, which is 6, and so on. And now we can let Mr. G tell us how many steps there are left to go. We can use the say function for this. So we can say I have plus, and then we use the str function to convert our steps left to go variable into a string, and another plus, and then the rest steps to go. And then Mr. G will actually step forward. Okay, let's try if this works. We start the game, and Mr. G now tells us how many steps he has left to go before every step he takes. Really nice. But what would we do if we don't know the amount of steps that we have to go in advance? Let's say Mr. G should walk forward until he sees a coffee pot directly in front of him. How could we do that? For this, we need to know whether or not there is some coffee pot in front of Mr. G. Well, let's open up Godot's help system again to see if there's something that can help us doing that. So we again click the search help button up here and we search for step forward. So we get to the page where we can see all the functions of Mr. G. Now let's scroll all the way up and then let's see what might be useful here. Here we have a list of properties. Now what are properties? Well, remember at the beginning when we were looking for functions and we found this section called methods. And then I said, method is just some special kind of function. And in a similar way, properties are a special kind of variable. Again, for this video, we're not going to get into the details about how methods and properties differ from functions and variables. So for now, let's just say these are variables that Mr. G has and that we can use these variables for our scripting. So what do we have available? Well, we have stuff with coordinates. There's a thing called all items before me. Well, that sounds like it could be useful. And we have a thing is item before me. And if we click on this, we get a description which reads, indicates if there is an item right in front of Mr. G. Is true if there is an item and is false if there is no item. So this is a Boolean variable and it can only have two values, true and false. Let's see if we can use this to solve our problem. So first we drag this cup of coffee into the tile directly before Mr. G. And now in our code, we remove this loop. And then let's see if Mr. G can tell us if there is an item before him or not. Now, how would we go about this? And you can again pause the video and experiment a bit. Okay, so we need to make a decision here. Is there an item before us or not? And if we need to make a decision, then we can use an if statement. So let's write if is item before me equals true, colon. Okay, so the editor is not happy about this. The error message says assignment is not allowed inside of an expression. Now what does that mean? Well, what we want is to compare the is item before me variable with true. But what we actually did is trying to change the value of this is item before me variable to true. Remember when we did our barista calculator function, we used the equals sign to change the value of a variable. But if equals means change the value of this variable, how can we compare it then? Well, for this, we can use the double equals sign, like this. So if is item before me, double equals true. And now the editor is happy, and we want Mr. G to say that there is an item before him. So we can use the say function for this. Well, we say, there is an item before me. Now, if there is no item before us, we also want to say something. So maybe let's add another if. If is item before me, double equals false. And then we say there is no item before me. So let's try this out. We start the game. And Mr. G tells us that there is an item before him. That works nicely. So now let's move the coffee cup by one field to the right and start again. And now Mr. G tells us that there is no item before him. Great. If we look at the code, we notice that the second if checks the exact opposite of what the first if checks. This happens rather often in programming, and this is why GDScript has some extra feature for this, the else keyword. So we can simplify our code to else say there is no item before me. And if we try this out again, we can see that our code still works. Okay, so now we can detect whether or not there is an item before us. But how can we combine this with a loop so that Mr. G will walk forward until he arrives at the coffee cup? We cannot use a for loop because then we need to give it a certain amount of steps, and we don't know the amount of steps in advance. But we can use a while loop. A while loop is very similar to an if statement. It repeats a piece of code while a certain condition is true. So we can say, while there is no item before me, so is item before me is false, we step forward. Okay, let's remove these two ifs and then start the program. And Mr. G walks forward until he stands right before the coffee cup. Great. Let's maybe move the coffee cup behind the blue field and start the program again. And now Mr. G walks all the way over here to the blue field until he hits the coffee cup. And we didn't even need to change our program here. Great. Okay, so now let's try one more thing. What will happen if we move the coffee cup one line up? So Mr. G will never hit it. Well, there's only one way to find out, so let's move it up and start the program. And now the program seems to freeze. And if we look down here, we can see that this text debugger has become red and there's a 1 behind it. And this indicates that Godot has run into some kind of error. So let's click on the debugger and then click on the errors tab. And we see an error message. Too many steps. Have you created an endless loop? And in fact, this is exactly what we did. Because Mr. G will never have the coffee cup before him. And so is item before me is going to be false all the time. And this means this loop is going to run forever. So with while loops, we have to be careful to not create an endless loop that will freeze our program. Unfortunately, this is something we need to take care of ourselves because the computer cannot detect the situation in advance. So for now, let's stop the frozen program by just clicking the stop button up here. And then let's put the coffee cup back into the line so Mr. G will not run into an endless loop. In the last hour, we learned quite a few things about the basics of programming, but we have really only scratched the surface. There are a lot more concepts to learn, but before we start learning new concepts, it is important that we actually use and fully understand everything that we have learned so far. What we learned in this video will not be enough to write our own game just yet, but it is enough to tackle some challenges. If you have downloaded and installed the example project, you can find some challenges in the challenges folder. Let's quickly have a look at this. So here we have a challenge 01, walking in circles. And if we open up the folder, we can see a few files in here. One ends with tscn. If you double click this file, the challenge will open in a new tab up here. And you can use the scroll and zoom buttons to have the scene nicely visible in your window. And here on the left-hand side, you now have some buttons that will show you some challenges to tackle. Let's click on the first challenge button. And here you can see the task. Write a program that lets Mr. G walk one time around the inner blue circle. To write this program, you click on the GD file that is next to the challenge, in this case, walking in circles.gd. And here you will see an empty function, what should I do, into which you can write your program, for example, a step forward. And when you want to try out your program, you just press the play button up here. If you want to try out another challenge, just click the button here on the left side. You can also come up with a challenge of your own. The more practice you get, the better. If you're stuck, there is also a solution.md file in every challenge folder which contains one solution for each challenge. Here are a few tips that will help you along the way. First, try to divide every problem that you get into smaller steps in your mind so you get an idea on how to approach it. For example, in this first challenge, Mr. G should walk around this circle of tiles. So try starting with a program that makes Mr. G just walk until the first edge, and then add more steps gradually until Mr. G walks the whole round. Remember that we write code in a programming language, and the computer is really a stickler for details, so you need to be sure that you have written everything exactly the way that we have learned. There are some mistakes that are made very often by new programmers, so let's quickly go over them. And the first one is indentation. So be sure to indent the code correctly, because indentation tells the computer where functions, loops, and if statements start and end. Also make sure that you don't mix tabs and spaces in your indentation. In GDScript, it is usually better to use tabs for that, because it's only a single keystroke. Another mistake that is made often is leaving out some of the punctuation. For example, there is a colon after a func declaration, and also after ifs, elses, for loops, and while loops. Also, when you call a function, you always need to add these parentheses, even if your function has no parameters. Another thing that may not be immediately obvious is that in GDScript, all code must be written inside of functions. The only thing that you can write outside of functions are variables. Finally, it really helps if you add some comments to your code, so when you read the code later, you still understand what you did there, and more importantly, why you did it. A comment that tells you why you did a thing is usually a lot more useful than one that just tells you what you did. So in this example, give a bonus of 2 coins for finishing early would be a much better comment than increase coins by 2. In this video, we learned the absolute basics of programming. We learned that programming is about finding the steps to solve a certain problem, and that we do this all the time in our everyday lives. We learned that programming a computer requires the use of a special programming language, and we had a look at how simple programs can be written with the GDScript programming language. We learned that code is written in functions, which can be reused and built into larger programs. And we learned how we can write our own functions that work on some piece of information that we give to them and process this information, like our coffee price calculator. We learned that we can use variables to store information so that we can keep track of things and don't need to repeat ourselves. We also learned that there are different types of information, like strings, numbers, or Boolean values, and that these types sometimes need to be converted in order to work with each other. And we learned that we can lock down the type of a variable so that we get early feedback from our editor when we try to combine variables that are not compatible with each other. Finally, we learned how we can make decisions with the if and else keywords, and how we can repeat code using the for and while loops. This is only the beginning of a long journey. In the next video, we will have a look at some more advanced data types like arrays and dictionaries, and we'll solve the mystery behind methods and properties. If you have questions about any of the concepts in this video, please post them in the comments. If you like this video, please give it a thumbs up and maybe consider subscribing to the channel to get notified when new videos are posted. Thank you very much, and happy Godotneering!